Hi everyone, I'm Phillip. Let's get the days closed out for, well, just today, but we'll have another day tomorrow. So I'll keep it not too long, don't worry. I'm sure it has been a long day in front of a lot of live streams. I hope you learned something. Let's close it out on a bit of a lighter note. I will not just make fun of stuff, but maybe we'll make some fun of stuff as we go along. So I want to talk a bit about observability is more than logs, metrics, and traces. I work for Elastic, the company behind Elasticsearch, Logsearch, Kibana beats the famous Elk or Elastic stack. We do work in that space, but I don't want to talk about our products today. This is more about the general ecosystem and where we belong and what we do or what we don't do. As always, questions on Slido. I'm trying to monitor questions while I'm talking. So if you have anything you want to throw in right in the middle, just do that. Maybe I will react, though I'm not super good at multitasking. So forgive me if I come back to the questions at the end as well. But don't hesitate to get in touch. Just keep the interaction going. So who is using logs? Before I want to go to the kind of more than logs, metrics, and traces, let's start at the basics, like what are the different pieces? Logs are probably the most common thing that people are using to keep track of what their infrastructure is doing. And I'm pretty sure you're using logs as well. Generally, it's you print at some point what is happening. And it's generally at the component level. So at one point in your code, you say, this is relevant information. This is what I want to output. This has been the classic and go-to thing that you have been using. But logs normally don't tell you such a great deal about the entire system and how that is behaving. For that, you often use metrics. Slightly less common normally, but also very widely used. Maybe Prometheus or some other metric solution that you can throw in there. And metrics are generally periodic measurements of some values. The nice thing about metrics is that you can aggregate them and get a very good overview of the entirety of the system. Like what is the average latency for any request we're serving right now? Also, that aggregation makes it very cheap to store the data long term because maybe at some point you don't need 10-second intervals anymore, but you want to kind of like aggregate into 1-minute intervals. And suddenly you only have 1/6 of the data that you had before. That's something you cannot easily do with logs. You cannot easily just throw away 5/6 of the data and you still get a good enough picture in many cases. So this is one of the nice attributes about metrics. Metrics just don't tell you much about the why something is breaking. It can just tell you, well, the system is in trouble, but I don't really know what is happening. For that, you might want to use APM, application performance monitoring, or tracing, often called distributed tracing as well. It's kind of similar to logs, but what the main difference is to logs is that this is now on the application level. So how tracing generally works is rather than you defining at this point, I output some log statement, it's more a request comes into your system and you give it a unique ID. And as that request propagates through your entire system, you always keep that ID and then you know what was part of this one request or transaction. And then you have, for example, the timing information or also the result. Was it a 200 or 500 or a 400 that you gave back? And you get much more context because you can see how it works throughout your system and which components it touches. So it is really on the application level, whereas logs are normally really just on one component level and it doesn't really give you much context what's happening around it. So that's the good side of tracing. Kind of the downside of tracing is that it can get pretty expensive in terms of how much data you need to collect. It has a lot more information, but probably too much. And maybe you don't want to keep them around forever because it's just a lot of data and wading through old traces can also be a bit cumbersome. Okay, now that we have covered what the three terms are where we have which are there and which are the foundation, but what is the more? What is the observability in that? And maybe you have seen this graphics. These are the infamous 3 pillars or the 3 tools that you want to use. It's what I've basically described. You throw them together and then you suddenly magically have observability. Or maybe you don't, depending on who you think is right in this debate. But generally what you have is we have metrics, tracing, and logging like I've described it before. And you can see that there is some overlap. And what you get, for example, if you combine metrics and tracing, you have request scoped metrics. So you could say for specific kinds of requests, what are the metrics? Like what are the response times for one specific endpoint here? Or we have request scope events. So give me all the logs for one specific transaction, for example. And you could then combine all of that, and that would give you request scope aggregatable events. And the idea is that you combine all these pieces of information, and then you get kind of a richer overview of your system. The idea is also that you don't have 3 different tools for that, but you try to combine them and then get the most out of the combination, because the whole is more than its individual parts, basically. But other people will say that this is a bit like calling gasoline, motor oil, and tires the 3 pillars of Formula One racing, which is not totally false, because you wouldn't have any Formula One racing. I mean, right now we don't have Formula One racing, but in general, you wouldn't have Formula One racing just by having these 3. You would not have it without them, but also it's not the entirety of what Formula One is about. So it's maybe not the full picture. And the same probably applies to, yes, logs, metrics, and traces are in observability, and there wouldn't be any observability without them. But it maybe doesn't tell you the entire story. And before we dive deeper into that, let's take a step back. We have kind of seen this before, that vendors have some solution, and then there's a fancy new term, and then you build some stuff around it, and then suddenly you have an ecosystem, or you have the tool for something. And where we probably have seen this before is DevOps. And then people make these fancy charts around DevOps tools. And it's not against any of these tools. All of those tools are good, and maybe you don't need all of them, but you will probably need many of them to have something that is a working DevOps pipeline, or whatever you want to call it. But DevOps is much more than just these tools. Just by throwing the tools together, you would not get what is DevOps, because DevOps, as we all know, is more about breaking down the silos and having more collaboration. And yes, the tools are vital to get there, but this is not the only thing that DevOps is about. And for observability, I think we have kind of the same problem. And coming from the DevOps world, something that plays very strongly into observability is also you probably have heard it, pets versus cattle. If you have not heard it, I will quickly repeat it. Previously, in the past, you used to have pets, or your servers were your pets. And for example, I remember a long time ago, like 15 or more years ago, when I got my first virtual server somewhere, it was like a pet. I gave it a name, I raised it by hand, installing all the packages. When it was sick, I tried to care for it and fix it, also because I could never reproduce what I had configured over weeks, months, or even years. And that model was kind of scary, because what happens if you cannot fix your pet? It dies and you're very sad. And the same thing often happened to servers, that they kind of died, and then people were very sad because stuff was just not working the way it was before anymore. And that's how we got to the cattle mentality. Cattle is this automated way. If you have the cows in the field, they probably don't have individual names. They're not really raised by hand, but more automatically. And if one of them is sick, you put them down, because they would otherwise infest the rest of your stock. And for servers, you can apply kind of the same approach. You don't give them names anymore. You don't raise them by hand. If a server is kind of faulty or behaving weirdly, you might just replace it, because you have it automated, so there is no harm in redoing that every now and then. And this entire mentality and approach has moved us from these static monolithic architectures, where it was pretty clear this is working or this is broken, and it was pretty binary, it was in one of these 2 states, to a much more complicated world with elastic microservice architectures, which is very fancy and buzzwordy, but mostly means it's much less clear of what is working and what is broken. And things will change pretty dynamically, because if you have a large enough system with many components, something will be broken pretty much all the time. And also, These are much harder to test because with that monolithic application, you deploy it and you know, yes, it's working, or no, it's not working. With that microservice, elastic, scaling, whatever architecture, it is much harder to say that this thing is working or is not working. So you will have much more fluid states. Probably you need to test in production because the integration with all the different pieces of data and integration that you have running and third-party services also make it very hard to reproduce that in a development environment. So life is getting harder. If you have tools to sell in that space, obviously that is like a great opportunity because people will need to invest much more into their monitoring. For example, I've once read that I think Netflix is investing more than 10% of all the spending on their infrastructure just on the monitoring or observability side of their infrastructure, just because they understood that once you have a complex enough system that is more in this elastic microservice architecture, you need to invest much more into that monitoring or observability. And obviously this leads to tools pretty much anywhere, but that's what we signed up for in this job anyway. And that kind of led to this development that DevOps, rather than the general movement or idea, is often more understood in terms of the tools or just the tools or just the department, which is kind of weird because DevOps originally was to break down the silos, and suddenly you end up with dedicated DevOps teams or DevOps jobs. And I get that because I recently looked up how much are you earning in different positions. So for example, if you call yourself a system engineer in the US, your salary is around $97,000 on average. But if you call yourself a DevOps engineer, suddenly your salary is almost 20% higher, just by giving yourself the nicer name. So the obvious movement that everybody is trying to do is, if I call my tools rather than monitoring tools, observability tools, can I sell them for 20% more? Who would say no to that? That's another reason why everybody is flocking to that new magic term, observability. And we've seen all of that in DevOps already. So while in the past you would say like, well, we should do DevOps, nowadays everybody says like, we should do observability. So let's take that look into what is observability actually, and not what it is not. So generally, observability comes from the general theory of control systems from Kalman, who was, I think, originally from Hungary, if I'm not mistaken. And the idea is you have an observable system if you can observe its state just by looking at its inputs and outputs. So even though you might not see everything in it, you can still deduce kind of the state of where you are. And that is the essence. This leads to the known and unknown parts in your system. This is another very well-known view of how to see that. And just to walk through that, you have the known knowns. These are things that you know and you are aware of and understand. This is normally what you have in dashboards, or some people also call it the scar tissue. Things that you have learned that broke in the past, and you know I need this dashboard to monitor what is actually going on here. These are the things you know and understand. Then you have the unknown knowns. This is maybe some metric that you collect and you know that is relevant. You're not sure how it might develop or how it might break in the future, but you can still monitor that. That is, for example, where you have machine learning or anomaly detection come into play, which is very helpful to analyze some metrics and you know how they used to behave in the past. And when they suddenly behave differently, you can throw an alert and say like, well, this is weird. Something is wrong here. Like, I know kind of like the area to watch out for. I'm not sure what will happen, but I can just monitor that. Then you have the known unknowns, things we are aware of, but do not understand. This is generally when you collect more data than you use today. This is this overcollection that gives you the chance that if something behaves in a weird way, that you can dive deeper later on to figure out what the hell is actually going on here. And then you have the unknown unknowns, things you are not aware of and do not understand. And there is no one solution to that. the general idea there is, again, you collect more data than you need today, but also you try to create richer events. So when you collect some piece of information like a log file for a login, you don't just create a log statement like login failed, but ideally you include the username, and you might include the IP address. So, is one specific IP address trying to log into one account again and again and it's failing? Do you have a brute force attack against many different user accounts from one specific IP addresses? All of these are like questions you might not have asked initially, but once you collect that and have these richer document structures, might make your life easier later on to answer complicated questions that you have not really been thinking before. But once suddenly stuff starts breaking, you can look into them. And what is also playing into that is the so-called survivorship bias. Maybe you have heard of this one. This was in the Second World War when the Americans had their planes flying over Europe. And when they came back, they would count like, where do they have bullet holes? And the original assumption was, well, you take the planes, wherever they have the bullet holes, we should probably reinforce them because that's where they are being shot. But when you think about it, actually, that doesn't make too much sense, does it? Because what you're interested in are not the planes that come back, but you're interested in the planes that don't come back. So actually, you want to reinforce the planes where they don't have the bullet holes, because probably on average, the bullet holes are more or less evenly distributed amongst the planes. But where you don't collect them when they come back, these are the planes that didn't make it back. So this is what you actually want to reinforce. And with monitoring, it's kind of the same thing. If you always focus on things that you have seen and that you know that are failing, you might overlook kind of like what is actually beyond what you might be thinking about right now. By the way, sometimes people point out that survivorship bias is kind of a more complicated story, and this is kind of like the children's version, but I'm fine with the children's version to get the point across here. But there are some very interesting articles about that if you're more interested in kind of like the history of survivorship bias and how it really developed and which people were involved, etc. If you're at home and bored, it might be something you can want to explore. Okay, so what you generally then get is you want to expose the state and find answers. So what is the status of my system? What is not working? And especially, why is it not working? Like with monitoring, you could easily say like, okay, this is broken. I don't know why. This doesn't really help you much in getting back to a working system. So you really want to answer this, why is something not working? Or I recently saw this tweet, and I think this is a good description of what you try to do here. Monitoring is more like your bank is telling you that you're overdrawn, like you have spent too much, but it doesn't really help you to fix the situation, like to learn how don't you get overdrawn. And observability is then that you're running out of money because you're spending too much of it on chocolates, cakes, and sweets. Because, well, you have recorded that and actually have the insights to go through the spending and like in which area you're spending every month. This is kind of like this difference in thought. One is telling you, okay, it's broken. The other thing is telling you, okay, this is broken, probably because of these reasons. And what you want to do then is you want to instrument your code so that you can answer new questions without shipping new code. Because especially in these elastically scaling microservice architectures, it's very hard to reproduce errors. And for better or worse, sometimes when you ship new code to actually figure out what is going on, like you add some log statements and then you redeploy your application, suddenly the error is gone. But probably it's not gone for good, but it might just return at some point later. And probably that is right when you're on holidays or sleeping, so it's not the best point in time. So you really want to figure out, why is this broken now? But if you redeploy, it might be hard to do. So the idea here is that you can answer new questions without shipping new code. And for that, you want to have the right instrumentation, like rich enough tracing to collect that. Tracing, like I said, is pretty expensive in terms of what you collect. So one thing that you often do is sampling. So sampling would mean like you have a lot of requests and you assume, since you have so many requests, on average, if you just collect, for example, 1% of all the requests, you will still get a good representation of the data that is coming to your system. So you might throw away 99% of the data or requests that come to your system, and that is still giving you a good representation. But unfortunately, sometimes you're not that lucky, because what you then would, or what is commonly done, is the so-called head-based sampling, where you basically, a request comes in and you say like, is this one of the 1% we collect, or is it the 99% we throw away? And you make that decision at the very beginning. What would be much smarter, and systems are slowly getting to that as well, is to make tail-based decisions. Tail-based decisions are basically like looking at the end of a trace and say like, do I want to collect this now or not? So if the request responded with a 200 and answered within 100 milliseconds, probably it was a boring request and you wouldn't learn much from that. But if it responded with an error or was slow, this is probably one of these requests that you might want to collect, because it might tell you something more interesting about the system. And that would be the tail-based approach of tracing. So this is just one of the ways where you might improve that. Okay, so we want to collect all the things, all the logs, all the metrics, all the traces, and maybe other pieces of information around. So for example, you might want to add health checks. If your system is working internally very well, but you have a bad DNS setting and nobody can access your service from the outside, or your internal monitoring on observability is not going to save you. And while you have logs, metrics, traces, like what is the law to have in observability, without health checks, you probably won't find out what your users are seeing from the outside. So this is just one of the things that's not really in those three pillars, but something that you might want to add. Or security might be another thing that might be very relevant. And that also leads us to another point, that not all signals are created equal. So for example, your users will care very much about that they can log in, that they can do a successful transaction, that the search works and responds fast enough, that they can put something in the shopping cart and then do the checkout process. That's what your users care about, and probably what you should also care about. What your users generally don't really care about so much is the API uptime, or the error rates that you have, or what the database latency is. Because if the database latency is a bit higher, but your users don't really notice it, do they really care? Normally, what kind of makes sense to focus on is focus on these things that your users are seeing and what is affecting them, rather than just internal metrics, which might be easy to monitor, but they don't tell you much about the business process and how that is working over time. Which leads us to service levels, which are famously used by Google, for example, and many others. So in service levels, you have the indicators, or service level indicator SLI, which might be you care about uptime. And then you have objectives. Like the goal is to have 99% uptime, which is not that much, by the way, but maybe that is your objective here. And then you have the service level agreement, where you basically guarantee to somebody else, and that somebody else could be another department in your company, for example, that this specific API will be up 99% of the time. And if it's lower, then you maybe owe them money because you're impacting whatever they're doing, or you have whatever agreement you find with another department or a customer. So for example, if you use a cloud service and they guarantee you some uptime for their services, if you have less uptime than that, you probably get some discount in your bill. And this applies pretty broadly to many other things. However, just as a note on kind of sanity, many people obsess over uptime, and it should be almost 100%. But if you look in reality, for example, looking at GitHub's uptime, it's maybe 99.9%. And that might not even be that high, because at least I see outages quite frequently. And well, they're bought for a good amount of money by Microsoft. Pretty much everybody is using them. Pretty much everybody relies on them. And if GitHub is down, not much work is being done, at least for us, because we have wikis there, we have the issues there, we cannot push code, we cannot release, we cannot test. Nothing works anymore. But still, they don't have 5 nines of uptime or anything. And still, everybody uses them and accepts that. So don't obsess over one single piece in your infrastructure too much, like uptime, because maybe the requirement is actually not as high as you might think. Okay, moving on. The other thing when talking about uptime is when you only monitor or care for your system when it's not up, maybe it doesn't tell you the full story. So I like this example where somebody says like, it's as if you try to learn how to keep a marriage healthy is by looking at divorces, which is pretty much what we do often in monitoring. Like if you don't know how your system behaves when it's working and how it should be, and you only look at things when they are bad and broken, you might not get the complete picture, or you might not learn how your system is generally behaving, or what are some signals that you might be concerned about, or like long-term fixes. So this is another thing that only looking at the broken parts or when a health check is failing might be not enough or too little investment into that area. And the next thing is you cannot buy observability. So what I mean with that is, let's look at logs since they're the most widely used example. So this is a classic log file here. So you can see we have a timestamp, we have a log level, I have the log message, I failed to log in with a 3-letter password, and you have, okay, whatever, wherever that happened. How did you get the log level? Maybe you wrote the regular expression to parse it out from a log line. Don't do that. Ideally, log in a structured format so you don't need to write regular expressions unless you like suffering, or sometimes people get so used to them that they just think like this is the only way to do it. I always say this is Stockholm syndrome, that you always write regular expressions to solve these problems. Don't. But again, I've mentioned this before, this example here doesn't tell you the full story. And also it's not very structured to get more information out. So for example, if somebody was trying to brute force my account, I wouldn't really get that from the parts that I have extracted here explicitly. What you would be more interested in, for example, is a richer event. So this I use here as a classic example for a log. Going to an event might look something like this, where you have the username that we extract explicitly, and we have the IP address. So this is localhost in IP version 6. We have the endpoint, and for example, we have the event type, so a login failure. And then you could easily graph out, for example, just from the log, how many login failures do we have? How do they distribute between users? Which IP addresses are involved in those? Those are all additional questions that you can just ask later on when you create those richer events and collect more information. So this is what you can do here. I've already said health checks might be something that you want to look into, maybe even synthetic health checks. If you've never looked into synthetic health checks, they are pretty much simulating user behaviors. So like you have a web shop, and the most common workflow is that you put something in your shopping cart and then you do a checkout on the shopping cart. And rather than wait for a user to fail in that, you have this script basically running continuously that will try this process every minute. And the process will alert you if it's failing. And rather than having a couple of users fail with your most important process, you maybe can catch it early on by having synthetic health checks, which actually simulate users so you can not use them as beta testers. Some people say that's what Microsoft used to do, at least in the past. But you can figure stuff out on your own before. Same goes for security that you might want to add there, or depending on what tooling your company is focused on. Some people would say that alerting is one of the main focus areas of observability, because if you do not alert quickly and frequently enough, nobody's learning anything from what you're doing. So that's just a point of view. There is no strict set of tools in observability. Again, you need to find what is working for you and what is important. Don't believe that there are exactly these 3 tools that you must use and this is the end of the road, because that's not what it should be. And as always, the goal, just as with DevOps, is the business value. It doesn't make sense to have like the most observed system if that doesn't add any business value and doesn't create a better product or happier users. It's just to have a product that is working well enough. And if you're GitHub and your availability is 99-point-something% and people are still using you, maybe that is enough. So please, GitHub, keep your uptime, because every time you're down is kind of annoying. So to wrap up, Monitoring is kind of like when you know what is happening and you know if the system is working or not. Observability is a property of a system and you know why it is working or not working. Like remember the account balance or knowing why you actually went broke, that's exactly that difference. Knowing if it's working or why it's working, that is kind of the differentiator. And while I've said that you cannot buy DevOps, obviously I can sell it to you, or many people try to sell it to you. Just don't believe that you can buy a product to get observability in your company. Same thing for DevOps. You cannot buy a DevOps and then you do DevOps in your company. It unfortunately doesn't work like that. Sounds too good to be true. Unfortunately, it is. Okay, if you want to get the slides, the QR code is for the slides, or you head to my talks and you will find that I think on the first page of slides. Observability is more than logs, metrics, and traces. And with that, I'm sure we have plenty of time for questions. Do we have any questions? Let me refresh Slido to see if there are any. I don't see any Slido questions yet. I guess the day was long and everybody ran out of questions. If that is so, that's fine for me. If you have still any, either write them in Slido now or just ping me on Twitter. My Twitter handle is this one down here. Other than that, have a good evening. And let me check. I should announce what we are continuing tomorrow. So tomorrow at 9 o'clock, we will continue with, and give me a second. Tomorrow we will continue at 9 a.m. with Steve Boone with the second keynote for value stream management. So he will kick off the morning today. Don't be late. If you have any questions, now is your final chance. Otherwise, that's it for me. Enjoy your evening. I hope you had a great virtual conference today. Final chance. Otherwise, I'll leave you for today. Well, thanks everyone for joining. Have a good evening. Bye.